Now there's another kind of linked list which is known as the circular linked list. Circular linked list is a kind of linked list in which there's no end of a linked list. So for example, if a linked list is like this, 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, and 4 is pointing to 1 itself again, right? So there's no tail node as such. There's no tail node as such, or you maybe call as the node which is pointing to the head. Maybe you start calling it as a tail. Right? Basically, no node in the given linked list will be pointing to the null. That kind of a linked list is known as a circular linked list. Okay, in which the tail is directly pointing to the head again, then this kind of linked list will be known as a circular linked list. Now, can you think of places where a circular linked list could have been used? So there's a circular table. It's just like that musical table that we play, right? In which we keep on revolving around the table, and suddenly the music stops and you stop it there, right? So it's also kind of circular linked list. Can you think of any application in the computer science where circular linked list might be getting used? You all guys are the computer engineers. I expect this answer. Hint, it's something related to operating system. See, circular linked list, as I say, is in a circular form. There's no end to it. So once I start running in a circular linked list, I will never, find an end. So I'll keep on running inside it. Okay. So any kind of place, any kind of situation where I just want to keep running in the loop, right? And every time I encounter a node, I do some specific action, right? So one of the applications can be scheduling, right? So for example, say for example in the operating system we have like 5 processes running at a time, right? And suppose it is a single core machine. So at a time only one process can be in the context, right? So what I do, I create a circular linked list of the 5 processes, and I keep on iterating the circular linked list. So as soon as I get a node 1, I just make the process 1 come into the context. Then when I just iterated the node 2, the process 1 was brought to the background, and again process 2 was brought to the context. And similarly, I keep on running on the circular loop one after the another, so that in a round robin fashion every process is getting the equal opportunity to get the resources, come into the context, get executed, and then another process will. So this is known as the multitasking, right? And this is what the circular linked list can be used in the operating systems. Similarly, if you have a concept called multi-threading, so again, if there's a multiple threads, right, and again, new thread has to brought into the context, right? So the thread scheduling is also an important thing. So again, whenever I have to do a thread scheduling, suppose I'm using round robin algorithm to bring the thread into the context, I'll try to create a circular linked list of that many threads, and I keep on iterating to the circular linked list. As and when I come to a particular node, I will awaken that thread to start the execution. Then I move to the next thread. I'll bring that thread down, and another thread will be awakened and will brought into the context. So like this. Okay. Now in a circular linked list, also if I have to define, every node is knowing only about the next node. Every node is knowing only about the next node. The only difference between a circular linked list and a simple single linked list is that the tail is now pointing to the head itself instead of tail pointing to the end. This is just the meaning of a circular linked list. So circular linked list also, if I have to define class circular linked list node, it will also have something called NCLL next. Okay. But now suppose if I have to traverse this public, how do I traverse circular linked list so that I don't go into an infinite loop? Any suggestion?
We can put a condition like when it starts, the next node should point to the head again.
Very nice. So what I do is that head is equals to null. I don't need to do anything. Okay. Then first of all, what I do is I print this value. System dot out dot print. Okay. And then what I do is let's node temp equals to head dot get next. What I need to do while temp is not, when I keep on iterating, it will again come back to the head because there's a circular linked list. So while temp is not equal to head, I just go and print this data. right? Make sense, everybody? Any doubt on the circular linked list, guys?
Yeah, I'm good. I'm good.
Yes, sir. I'm also good.
Paritosh? Cool. So if this is clear, I want you to try these questions on the circular linked list also. It is very pretty simple, but I want you to write this code at least once. Instead of this, you just have to pass this one. Cool. So you need to implement this. So with this, I think we have covered almost everything in the linked list as far as theoretical concepts is concerned. One thing is left, which is the memory efficient linked list. We'll cover in the next session. I will get started with the stack in the next.